So we have next topic, that is enthalpy of neutralization. Neutralization means a reaction between aqueous solutions of an acid and base. Means we have acid, aqueous solution of acid that will react with aqueous solution of base and give salt and water. So this type of reaction when takes place, it is generally exothermic in nature. So heat is evolved in the neutralization reaction. So what is enthalpy of neutralization? It is the change in enthalpy which takes place when one, say in every case, now keep in mind, in other cases we use one equivalent, okay, 1 mole. Now here we use 1 equivalent, okay. What we use? 1 equivalent of acid and base, right. So क्या होगा? It is change in enthalpy. I will write the definition. It is change in enthalpy when, yes, so change in enthalpy which takes place when 1 gram equivalent, when 1 gram equivalent of acid and a base present in their dilute aqueous solution, present in their dilute aqueous solution, neutralize each other, okay. So that is called enthalpy of neutralization, okay. It is denoted by delta NaOH. बेटा इज इट विजिबल टू यू? दिख रहा है पूरा? यस बोलो बेटा, अच्छे से ये दिखाई दे रहा है पूरा? ओके, पता नहीं मेरे फोन में क्यों नहीं दिखाई दे रहा है। हाँ अब ठीक है, ओके ओके ग्रेट। सो से enthalpy of neutralization is the change in enthalpy when 1 mole of not 1 mole, say 1 gram equivalent of an acid react with 1 gram equivalent of base, okay. For example, an acid and base has their aqueous solutions. For example, aqueous solution of sodium hydroxide react with 1 gram equivalent of aqueous HCl to give NaCl aqueous along with H2O liquid, okay. And in case of strong acid and strong base, value is fixed, value is fixed. So keep in mind, for enthalpy of neutralization of strong acid and strong base, that is always equal to minus 57.1 kilojoule, or in terms of kilocalories per mole, it is minus 13.7 kilocalorie. Okay. So it means, 1 gram equivalent of acid means, yes, anybody who can say, what do you mean by 1 gram equivalent? Why we use 1 gram equivalent? 1 gram equivalent of acid, it gives 1 gram equivalent of acid provides only 1 mole of H plus ions. Keep in mind, only 1 mole of H plus ions, and 1 gram equivalent of base, it provides मुकेश झा सर, अच्छे हैं बेटा, provides 1 mole of OH negative ions. Okay. Say 1 gram equivalent of acid provides only 1 mole of H plus ions, and 1 gram equivalent of base provides 1 mole of H plus ions. Okay. Got my point? That's why, that means if they provide 1 mole of H plus ion or 1 mole of OH negative ion in aqueous solution, right, when completely ionized. For example, see, if we have HCl, H2SO4. Now, if you look at it, HCl will give 1 mole of H plus ion, and H2SO4 will give 2 moles of H plus ions. Am I right? But if we talk about equivalents, see, that is the major difference. Okay, 1 mole of HCl gives 1 mole of H plus ions. Okay, and 1 gram equivalent of HCl also gives 1 mole of H plus ions. But if you talk about H2SO4, then 1 mole of H2SO4 gives 2 moles of H plus ions, but 1 gram equivalent of H2SO4 gives 1 mole of H plus ions. Means it is independent of their basicity. Any acid, if it is 1 gram equivalent, then it will give only 1 mole of H plus ions. I think now it's clear to you. What do you mean by 1 gram equivalent? Now, next, 1 mole of sodium hydroxide gives, yes, 1 mole of sodium hydroxide gives 1 mole of OH negative ions, and 1, you can write it like this also, 1 gram equivalent of sodium hydroxide gives same, okay, because their acidity is 1. But if we have 1 mole of calcium hydroxide, then it gives 2 moles of OH negative ions, but 1 gram equivalent of calcium hydroxide gives 1 mole of OH negative ions, right? Got it बेटा? Enthalpy of neutralization जो है of a strong acid and a strong base, that is always constant. तो ऐसा क्यों होता होगा, बोलो बोलो बेटा. जैसे मैं क्या करूं, मैं एक लूं सोडियम हाइड्रोक्साइड और उसके साथ लूं HCl, दूसरा लूं सोडियम हाइड्रोक्साइड और HNO3, तीसरा लूं पोटेशियम हाइड्रोक्साइड एंड HCl, फिर पोटेशियम हाइड्रोक्साइड एंड H2SO4. ठीक है, समझ गए? तो इन फर्स्ट केस ही, सेकंड केस, थर्ड केस, फोर्थ केस, इन सब केसेस में NaCl एक्वस और क्या बनता है, H2O लिक्विड. क्लियर? तो अब स्ट्रॉन्ग एसिड जितने भी होंगे, अगर वो 1 इक्विवेलेंट है, स्ट्रॉन्ग एसिड अगर 1 इक्विवेलेंट है ना, तो वो 1 मोल H प्लस देगा, और स्ट्रॉन्ग बेस अगर 1 इक्विवेलेंट है, दैट विल ऑल्सो गिव 1 मोल ऑफ OH नेगेटिव आयन. दैट्स वाई देखो ये H2O की फॉर्मेशन जो है, मतलब सिंपल सा फंडा है कि ये जो जितने भी आप करोगे, NaOH क्या हो जाएगा, Na प्लस OH नेगेटिव, HCl क्या हो जाएगा, H प्लस Cl नेगेटिव, और NaCl Na प्लस Cl नेगेटिव एंड H2O लिक्विड. सो Na प्लस कैंसिल, Cl नेगेटिव cancel. What is left? OH negative ion plus H plus ions to give H2O liquid. Okay, and therefore their enthalpy of neutralization is always equal to minus 57.1 kilojoule. So इसका मतलब ये हुआ कि it can also be defined as formation of enthalpy change when 1 mole of H2O is formed from 1 mole of OH negative ion and 1 mole of H plus ion. Am I right? So that's why this OH negative ion 1 mole, it is obtained from 1 gram equivalent of base. And what about H plus? It is obtained from 1 gram equivalent of acid. Am I right? So that means any strong acid or strong base, if 1 gram equivalent of strong base is there, it will always give 1 mole of OH negative ions. Any strong base, any strong acid, if it is 1 gram equivalent, it will always give 1 mole of H plus ions, right? So therefore it forms 1 mole of water. right? So it will give 1 mole of water. Am I right? Any doubt up to this? That's why it is always constant. Its value is always constant. But what happened if we have, say, if I write here H2SO4, so it should be written as half H2SO4, so that it will give, or simply 1 mole of H plus ion. So you can write it as KHSO4, or if you write it as KHSO4 as well as H2O liquid. Okay, done. Okay, or if you write it as 2 KOH and 1 mole of H2SO4, then it will give double enthalpy of neutralization, just double of the value. Means it is simply the enthalpy change or energy released when 1 mole of water is obtained. 1 mole of water is formed from 1 mole of OH negative ion and 1 mole of H plus ions. Now, let us say we have acetic acid, okay, and it is treated with sodium hydroxide. 1 gram equivalent of acetic acid, 1 gram equivalent of sodium hydroxide. Now tell me, in this case we have weak acid and strong base. Weak acid and strong base. But in this case, can you tell me enthalpy of neutralization value, energy released, is more or less? Tell me, energy released is more or less than the value of strong acid and strong base? Is it more or less? It should be less than the value given to you. Okay, it is experimentally, its value is minus 55.2 kilojoule. Sorry, theoretically. Okay, so where the rest value goes? Energy released is less. Very good, Ralam. So tell me where the value goes, because in case of strong acid and strong base, when we have NaOH aqueous along with strong acid like HCl, value is what is the value? Minus 57.1 kilojoule. So tell me this difference in value, why is it there is a difference? Beta ji, something else is there, because you know a weak acid or weak base is not completely ionized, that you know is not completely ionized by its own in aqueous solution. That's why it is called weak acid or weak base. But in case of strong, it has to be ionized fully in order to complete the neutralization reaction. So to ionize it, some energy is needed. Some energy is needed. For what? To neutralize it completely. Okay? To ionize it completely. So small amount of energy is used to ionize it, because weak acid like acetic acid is ionized feebly. Okay, so to ionize it fully we have to give extra energy, so that energy it will absorb. Okay, that's why enthalpy of neutralization is less. Okay, that means enthalpy of neutralization of weak acid versus strong base or weak or strong acid versus weak base is equal to enthalpy of neutralization of strong acid versus strong base plus enthalpy of dissociation of weak acid or weak base. So this is the actual funda. Okay, like see, it is, it is always constant. This enthalpy of dissociation is variable. That's why enthalpy of neutralization of a strong acid by a weak base and vice versa is not constant. Okay, so that is in case of acetic acid, let us say it needs energy 1.9 kilojoule to get completely ionized. That's why the value comes out to be minus 55.2 kilojoule. Okay, because this dissociation enthalpy is always positive, this is always negative, right? Yes beta, any doubt up to this? बेटा कोई डाउट है यहां तक जितना किया हमने? सेम अमोनियम हाइड्रोक्साइड प्लस HCl, so it give ammonium chloride and H2O liquid, and its enthalpy of neutralization is equal to minus 51.5 kilojoule. So tell me, say this is weak base and this is strong acid. So tell me, what is enthalpy of dissociation of ammonium hydroxide? Because to calculate enthalpy of neutralization of weak base, that is ammonium hydroxide, versus HCl, it is equal to enthalpy of neutralization of strong acid and strong base, that is 57.1 plus enthalpy of dissociation of ammonium hydroxide, right? So enthalpy of neutralization is given to you, it is minus 55.2 equal to minus 57.1 plus enthalpy of dissociation of ammonium hydroxide. So enthalpy of dissociation of ammonium hydroxide is equal to minus 55.2 plus 57.1. Okay. So, value comes out to be it is minus 55, okay, sorry, minus 51.5, sorry, minus 51.5. So, value comes out to be 5.6 kilojoule. That's it. Great. Okay, in the same way we can calculate in amount of heat evolved in various cases. So, let us do one question. Calculate the heat evolved when, first question is 0.25 mole of hydrochloric acid in solution is neutralized by 0.25 mole of sodium hydroxide solution. Yes, what is the value? Calculate it. Calculate the value. Second is 0.5 mole of nitric acid is mixed with 0.2 mole of potassium hydroxide solution. Okay. बोलो बेटा. And third one is somewhat difficult, but you can do it. 200 ml or centimeter cube, you can say 200 ml of 0.2 molar hydrochloric acid solution is mixed with 300 ml or centimeter cube of 0.1 molar sodium hydroxide solution. Yes, beta. So, what is the value? Very good. It is minus 14 point around about 30 minus 14.275. Ralam, very good. Or we can write it as heat evolved is equal to 14.3 kilojoule, simple. Okay. So, in the first case we have 0.25 mole of HCl and 0.25 mole of sodium hydroxide. So, the reaction between HCl and sodium hydroxide, that will give sodium chloride aqueous along with H2O liquid, or simply it is the reaction between H plus aqueous, OH negative aqueous to give H2O liquid. But see, we have 0.25 mole of HCl, 0.25 mole of OH negative ion. So, when they react, they will, and their acidity is 1 mole. Okay, that's why, and both are strong. That means if we talk in terms of their enthalpy of neutralization, so that is 57.1. okay, or you can write because enthalpy of neutralization is minus 57.1 kilojoule. Okay, so that means heat evolved when 1 mole of 1 gram equivalent, or here 1 mole is same because acidity is 1. When 1 mole of HCl is neutralized by 1 mole of NaOH aqueous, then its value is 57.1 kilojoule, right? Because we will write in terms of heat evolved. Okay. So now heat evolved when 0.25 mole of HCl is neutralized with 0.25 mole of NaOH aqueous. So for 1 mole it is 57.1. So for 0.25 mole it is 0.25 into 57.1. So value comes out to be 14.273, or we can write simply 14.3 kilojoule. Okay. Now second one. Second is 0.5 mole of HNO3 and 0.2 mole of KOH. What is the value? HNO3 as well as KOH, both are strong. HNO3 is a strong acid. Beta, when we use heat evolved, so negative sign is in it. If you write delta H, then value you should write negative sign. Ralam, got it? If you write heat evolved, then there is no need to put negative sign. Negative sign means heat, it is exothermic, heat is released. Okay, but if you write in words, that is, it is heat evolved, so it should be without negative sign. Mansi, very good. Value comes out to be 11.4. Wow, great. Very good, Mansi. So here reaction is HNO3 plus NaOH aqueous. So it gives NaNO3 aqueous plus H2O liquid. Okay. So now say HNO3 will give H plus ion and OH, NaOH will give OH negative ion to give H2O liquid. So say there is 0.5 mole of HNO3, so that means H plus ions are 0.5 mole and OH negative ions are 0.2. So which one is limiting? OH negative. So that means it is like this. There is a formation of only 0.2 mole of water from H plus and OH negative ions. Okay. So heat evolved when 1 mole of HNO3 is neutralized by 1 mole of NaOH, it is 57.1 kilojoule. Now heat evolved when 0.5 mole of HNO3 is neutralized by 0.2 mole of sodium hydroxide. That means out of 0.5 only 0.2 will be neutralized, rest remains in the solution. So you can write here 0.2 only. So that means this is a case of limiting reagent. Okay, so 0.2, so value comes out to be 11.4. It is negative, but value we write it as positive. Why? Because we write here heat evolved. So it itself means negative value. Okay, I think you got the point. Last one. So you should say that how many moles of water are formed from the acid and base, because acid will provide H plus ions, base will provide OH negative ion. So when they get neutralized, how many moles of water are formed? Because if 1 mole of water is formed from 1 mole of H plus ion and 1 mole of OH negative ion, then energy released is 57.1 kilojoule. If it is less than or more than that, you should multiply it accordingly. Now third question. See, we have 200 ml of 0.2 molar HCl. It is mixed with 300 ml of 0.1 molar KOH. So you know reaction is same as we have done earlier. It is like this only, and you know HCl is a strong acid, sodium hydroxide is a strong base, both are strong. Okay, so they give same number of H plus and OH negative ion. From this, calculate number of moles. So you know molarity equal to number of moles over volume into 1000. That implies number of moles equal to molarity into volume over 1000. So number of moles of HCl is equal to molarity into volume in ml or centimeter cube divided by 1000. So solve it, we get 0.04. So same number of H plus ions. So number of moles of H plus ion is equal to 0.04. Now come to second one. Number of moles of sodium hydroxide is equal to molarity into volume divided by 1000. So it comes out to be just 0.03, or number of moles of OH negative ions is equal to 0.03. Now I think you can calculate. See, H plus 0.04, OH negative 0.03. So that means OH negative ions is limiting reagent, H plus ion remains unreacted, it becomes 0. So we get 0.03. Okay. So heat evolved when 1 mole of HCl is neutralized with 1 mole of sodium hydroxide aqueous is equal to 57.1 kilojoule. So heat evolved when 0.03 mole of HCl is neutralized with 0.03 mole of sodium hydroxide is equal to 0.03 into 57.1. So value comes out to be 1.71 kilojoule.